Hey guys, week number 2, calculus as well as some prob and stats. So I'll start with some calculus problems. They've also got some functions type work as well, but we'll get to it. So number 3, quite a few parts here. So I'm going to start with part A, obviously. I'd asked for the inverse of the function f of x, which equals e to the 3x plus 1. So in finding the inverse in part 1, what I would do is just change the variables for x and y and solve for y. So that would be 3y plus 1 is equal to ln of x, subtracting 1 and then dividing by 3, you would get y, which will be the inverse of f, which would be ln of x minus 1 over 3. In part 2, it asks for the domain of the inverse. That's going to be equivalent to the range of the original. So the range of f of x, it looks like it will be from 0 to infinity, right? Therefore, the domain of the inverse will be equivalent. All right, let's move on to part B. 5 marks here. So it looks like I did not leave a whole lot of space for it, but we'll continue mission here. G is defined as ln of x, where x is all positive real numbers. The graph of G and the graph of f inverse intersect at a point. Find the coordinates. So f inverse from part A was ln of x minus 1 over 3. I want to know where that intersects g of x, which is ln of x. I guess what we could do here, let's see what we can do. Let's multiply both sides by 3, giving us ln of x minus 1 is equal to 3 ln of x. And then I'm going to do a little something here. I don't know if it'll turn out to work out very well, but let's do it. I'm going to use properties of logs. And 1 here is actually equal to the ln of e. So I have ln of x minus ln of e, which is equivalent to ln of x over e. And on the right side, I have the ability to bring that 3 up as an exponent. So it'd be ln of x cubed. And therefore, I don't know why I put that so far up there in the argument, but whatever. Then x over e should be equal to x cubed. And this is kind of interesting, but let's bring this up here. Let's say that then x is equal to e x cubed. And let's set that equal to 0. So e x cubed minus x is equal to 0. So I'm going to factor out, what do I want to factor out here? Let's factor out an x. So take out an x, I get ex squared minus 1. This is kind of weird, but this would be true at x equals 0, which can't happen, right? Because ln of x only exists in the positive real numbers, so that's really not going to give me an answer at all. Wherever this is true, I'm going to have a solution. So I'm going to add 1 divided by e, so x squared equals 1 over e. So x equals plus or minus the square root of 1 over e. And since my x values have to be positive, that would mean that I would have 1 over root e. Another way you could write that, if there is multiple choice on an exam for whatever reason, you could write that as x equals e to the negative 1/2. It's a cool one. Let's move on to part C. The graph of G intersects the x-axis at Q. Okay, so I gotta remind myself what was G. G is ln of x, okay. G equals g of x equals ln of x intersects the x-axis at q. Well, I know ln of x is equal to 0 at x equals 1, right? The graph of ln of x looks something like that with a vertical asymptote at x equals 0. Show that the tangent of t to the graph of g at the point q is x equals 1. All right, so I want to know the tangent line equation right there, and I want to show that that's equal to y equals x minus 1. All right, so two things I need. I need g prime. G prime of x is 1 over x. That's the derivative of g. So g prime at 1 is equal to 1. That's cool. And so now I have a slope, but I also need a point. So I need to know what g of 1 is equal to, and I already knew that, so it's equal to 0. Therefore, the tangent line equation is built by using a point and a slope. So y minus a y value, which is this one, is equal to the slope, which was 1, times x minus an x value, which was also 1. So I simplify and I get y equals x minus 1. There we go. Absolutely awesome. There is q right there. And t is this line here, that equation of the tangent line. All right, region R is bounded by the graph of g and the tangent line t and the line x equals e. Find the area of R. So let's quick graph this, just a small one. Okay, so here's x equals 1. Oh wow, that was very poor. Let's try that again. That's better. There is g of x. Let's go here is e. R is bounded by the graph of g of x, which I have graphed. The tangent line t, let's graph that in red. And the line x equals e. Let's just give us a nice little... So this blue space here, it's not perfect, but it's a good try. That's R. Okay, we got to find that area. So that area would be from 1 to e of upper function, which in this case will be x minus 1. Okay, this is not great, but whatever, we can handle it. Okay, minus the lower function, which is g of x. So that would be, I guess I have it in black. Dx. Now, boy, this is not a real nice problem because you're gonna have to use integration by parts to integrate ln of x. I mean, clearly it'd be easy to integrate this. That will be x squared over 2 minus x minus, I believe the integral of ln of x, I mean, we could go about it if we want to. I'm actually going to go off camera for just a second and confirm it. Yeah, so I believe it ends up being x ln of x minus x. Okay, and we're going to evaluate that from 1 to e. Now, let's simplify this slightly. This would be x squared over 2. And then you'll see that this negative x and this negative x will reduce. They'll go away, whatever. And I'll have this, right? So I'm going to evaluate that from 1 to e. And it looks like I get e squared over 2 minus e. Okay, that would be if I plug in, because the ln of e is 1, right? And then subtract 1 squared over 2 minus 1 times 0, which comes out to be, oh boy, I'm just going to keep it simple here and not try to reduce anything, but e squared over 2 minus e minus a half. I might have gone further on my key, but that would be the best I can do for right now. Okay, now in this part it says show that g of x is less than x minus 1 for all real numbers. Okay, and then by replacing x with 1 over x in part E, part I, show that x minus 1 over x is less than g of x for all x in the real numbers. Okay, so part 1, let's see if we can sketch this. It's asking us to show that g of x is less than our tangent line, which was y equals x minus 1 for all values greater than 1, or all real numbers, I suppose. Well, we know that they're equal at q, and the slope of this tangent line is 1. G of x, its second derivative is negative 1 over x squared. So g prime of x was 1 over x. Since the second derivative, since g double prime of x will be less than 0 for all x in the positive real numbers, then it will be concave down and therefore will always be less than our tangent line. Therefore, g of x, I shouldn't have wrote that, but g of x will be less than or equal to x minus 1 for x in the reals that are positive. Okay, cool. So by replacing x with 1 over x in part EI, okay, so let's do this quick. So for part 2, okay, so for part 2, we're going to replace x with 1 over x. So I think I'm recording here. Yeah, I am. We're good to go. So I'm going to replace g of x with g of 1 over x. Okay, and I'm going to replace, of course, x with 1 over x as well. So that would be ln of 1 over x less than or equal to 1 over x minus 1. Now I could pull out a negative, which changes this to now ln of x less than or equal to 1 over x minus 1. And then I'm going to multiply both sides by negative 1. And when you do that, almost forgot, you're going to change your inequality, which will make this 1 minus 1 over x. And with a simple manipulation, finding common denominator, I've now shown that the following is true. And therefore, we're done. All right, don't write that in the exam, but there you go. And that's true for x in the real numbers. Right? All right, cool. I think that's it. Yep, that's it. So that's problem number 3. Let's see, that's 6, 5, 3. That's 14. 14 and 9 more. That's 23 marks. That's a sizable problem, and most of that is pretty accessible. So there you go. It's problem number 3. Have a great day. See you next time.